welcome everyone to another edition of Fireside Chat at Cohere For AI. I'm very excited today to have Jacob with us. He is an associate professor at MIT at the Department of Electrical Engineering and Computer Science, as well as the Computer Science and Artificial Intelligence Lab. His research has been aiming to build intelligent systems that can communicate effectively using language and learn from human guidance. He has earned his PhD from the University of Berkeley, his master's from Cambridge, and his bachelor from Columbia. He has been named a Kavli Fellow by the National Academy of Science and has received the NSFR Career Award, MIT Junior Boss, and Colloquatrons Teaching Awards, and several paper awards during his career. I'm very glad to have you with us, Jacob. Welcome.
Yeah, thank you for the invitation.
Okay, so I do want to start by maybe asking you to tell us a little bit about, in your own words, about your journey in your career. So I know I just went through the maybe big milestones, but about the hows and whys that you picked each decision during your career to get to where you are now.
Yeah, so, I think going all the way back, I think I knew relatively early on that I wanted to do something adjacent to artificial intelligence. I don't know, I did a bunch of programming as a kid, read a bunch of science fiction novels, and that felt like an important problem. And I think this was at a time when none of this technology really worked for much of anything at all. And various people that I talked to about this in college still thought it was like a little crackpot or a little crazy to be choosing this out of all of the things that one might be able to do as a computer scientist. But yeah, so when I got to college around the end of my freshman year, I just kind of spam emailed everybody in the department that was doing anything remotely related to AI, and the natural language processing people got back to me first, and here I am, however many years later. That's a little bit facetious in the sense that I have done a bunch of work on, sort of at the boundaries of NLP and the boundaries of NLP, or NLP and vision and NLP and robotics, and have always just found the kinds of weird random projects that people do at NLP conferences to be a little more exciting than random projects everywhere else. And, I think sort of fundamentally, as we're now learning with big, everything that's going on with big language models, a lot of the kind of basic questions about intelligence, about human cognition, show up much closer to the surface when you're trying to work with language data than when you're trying to work with anything else. So in that sense, it was a great kind of way into this more general thing. So yeah, and so I started doing that. I started working in Kathy McEwen's lab first. And I guess generally one of the things that was really nice about Columbia, both then and now, is that it was a real kind of NLP powerhouse, and there were a bunch of people working in a bunch of different areas in the field. So I worked with Kathy and got a kind of good general overview of what everyone was doing. I spent a bunch of time working with Nizar Habash and Owen Rambo on machine translation problems, and that was a real great introduction to kind of ways in which linguistic insight can contribute to system building, and actually thinking about the interaction between NLP and sort of real syntaxy things. And then Mike Collins showed up my senior year, and I was able to work with him on the more kind of machine learning aspects of the problem. Yeah, that was college. And then I don't know, I did this master's degree at Cambridge for the year and did a little research, which was frankly not very good, and mostly just kind of sat by the river and read and thought about what I wanted to do. And that was actually a really good preparation for the PhD, in the sense that in undergrad, I think had just been, kind of head down working and not thinking too much about what the big important problems were. So yeah, and I guess from there to a relatively normal academic career progression, did my PhD, spent a year doing a postdoc in industry, and now I'm at MIT.
Yeah, that's amazing. So I'm actually curious, what were you reading by the river? So was it just new papers in different fields, or just
No, so it was mostly Wittgenstein, actually. So funnily enough, the house that I was living in Cambridge had belonged to his doctor, and he had died in one of the upstairs bedrooms. And, you know, either because of that or because I had taken a philosophy of language class also my senior year of college, and felt like I hadn't really sort of processed everything that was going on, and probably still today haven't. But, you know, I don't know, somehow felt apt to like go back and do a bunch of philosophy of language reading while I was there, you know, in ways that I think actually were pretty impactful for the kinds of projects and the kinds of even like modeling decisions that showed up in some of the first couple of things that I did during my PhD. So, you know, there was that, and, you know, I guess one of the nice like general things about being at a university and with my sort of particular friend group there was like everybody worked on different things, and there were a bunch of biologists and a bunch of physicists, so also, you know, some amount of like thinking about those things as well. The college we were in, there was like a little graduate student bar, and people would, you know, go there in the evenings, and there'd be, you know, science and nature on the magazine rack, and you'd just sit there like reading Nature with a glass of beer or something. And I don't know, it was very pleasant.
Yeah, that sounds great. Yeah, and I do find it very interesting. So you mentioned this, your interest in philosophy of language. I do definitely feel like I see that thread in some of your works on just compositionality and this like semantics, like the logic behind like how language works. So it's really great to hear like where maybe the seeds came from for that line of work. And so I was wondering, because you also mentioned about like one of the great things, I think at Columbia you mentioned that there were these different labs, different people working on different projects. So in general, so at the time as maybe like a junior student, how did you find collaborating with people from maybe these different labs? And what would you now, with your experience, like what would you recommend for people who wants to find collaborators uh, and they don't know maybe how to do that or where to start?
Yeah, so I guess I want to acknowledge starting out that it's probably, you know, much the barrier to, well, the technical barrier to entry is much lower in the sense that, you know, I feel like the tooling is much better. The sort of amount of machine learning sophistication that you need to like actually be able to make meaningful research contributions is lower than it was then. But as a result, you know, certainly the number of people who are looking to do research in this area, and if you're a faculty member at a university, the number of people who are emailing you saying, "Hey, can I work with you?" Is a lot higher. And you probably can't, just as I did, you know, send an email saying nothing more than like, "Hey, I would like to do some research in this area." And so, you know, one thing that I guess now being on the other side of that is always helpful is when somebody's starting to, you know, looking to start a research collaboration, especially somebody who's like, you know, an undergrad just at the beginning of their research career or whatever, has made some effort to sort of read about what a given research group is doing, and, you know, writes an email saying, "Hey, I'm interested in working together. Like, here's a specific question that I had about this paper, or here's a, you know, extension that I would be interested in pursuing of this thing that your group is doing," and just showing that you've spent some time, you know, thinking about what's already going on there, and ways in which that particular, you know, you could contribute to that particular collaboration, or you could get things out of that particular collaboration. And, you know, I think then sort of being able to make those kinds of suggestions, ask those kinds of questions, is a sign that you're like at a level of preparation where you can contribute meaningfully.
Yeah, that's definitely very good advice. And
And I guess I might also add to that, you know, that maybe sort of in the same way that I did when I was starting out, it also doesn't hurt to just like cast a wide net and to talk to as many people as you can, and reach out to as many people as seem relevant and interesting as possible, just because, you know, often it's hard to figure out if you're gonna like actually have a good like personal fit until you've had a one-on-one conversation, or you learn things about research in the course of having those conversations that can inform your choice.
mm, yeah, and so now that you are at the point that you are now having your own group and supervising students at different levels, uh, what is your general uh, attitude toward these like collaborations, or like general uh, approach for your students, like if they like internal or also external collaborations?
Yeah, I mean, I love it. I like the ability to work with, or the opportunity to work with other people who are experts in things that you're not an expert in is, in my mind, one of the sort of most appealing things about academia. Um, I would say a large majority of the papers that we write in my group involve somebody from outside the group, and usually um, the way in which those things come about is we're going down some route, we're starting some particular project, and we realize that there's some toolkit that we don't have deep familiarity with, or some application that we haven't spent a bunch of time thinking with, and immediately say, okay, who do we know, or who do we know of that is an expert in this area that could like teach us how to do this thing, and then they join on with the project, and often those things then turn into like multi-year, multi-project collaborations. Many of the students that I advise right now actually started out because I was sort of brought in as the language person in that same role for projects that they were working on, and then we enjoyed working together so much that we wound up, sort of like formalizing the advising relationship.
Yeah, that's great. I think that's also like just showcasing one of the really nice things of doing open science, and which happens at academia now, maybe less and less at companies. That is just great to bring people from different expertise together to share and work on problems together. Nice. So I do want to ask, I mean, we definitely have to talk about language models and what has been happening in the past few years. Uh, I want to start by just asking about your general thoughts about what you think these models, in your opinion, are actually capable of doing currently, maybe despite the hypes, and what do you think about what what potential they have, and like what we can do with them more next.
Yeah, so I mean that's a very big question. I guess to sort of free associate answers to it. So I think one thing that has become clear is that in the course of becoming a very, very good next token predictor of the kind that we have right now, you have to learn a bunch of stuff, not just about the structure of language, but at some level about the structure of the world, right? And that as much as these models sort of make factual errors, contradict themselves, hallucinate, somewhere inside the parameters inside these models is some uh, store of information about how the world is and how the world works, and that's encoded to varying degrees of reliability, and probably more reliably for the sort of facts and topics that people tend to talk about in the corpora that gets scraped for training these models, and their English language biases there, and things like that. But um, that fundamentally what we are dealing with now are more than just uh, sort of fancy autocomplete models that know what kinds of words are statistically likely to come next in a sentence. But what's tricky about that, right, is that they then don't exhibit, so can do things that you couldn't do with a for lack of a better word, a pure shallow pattern matching model, right? You can ask factual questions and usually get correct answers. You can ask for code to get written and usually get code that looks like it sort of does the right thing. And we're therefore inclined to ascribe to these models all kinds of properties that we ascribe to the only other systems that we know that produce language with the same degree of fluency, which is people. And they're certainly very unlike people in the process by which they map from inputs to outputs, or by which they produce language, right? And if we forget about sort of all the other or most of the pieces of the modern training pipeline, and we just think about what it means to be a really good next word predictor for all of the tokens on the or all of the text on the internet. Right, the internet was written by a bunch of people writing at a bunch of different moments in time when different facts were true, and they didn't all agree on what those facts were at the moment that they were writing. And the degree to which they express their opinions online doesn't necessarily reflect the correctness of those opinions or even the sort of prevalence of those opinions within the population at large. And so what a language model is a model of that entire population. And when you draw a particular sample from it, you don't know, which piece of the population is being sampled to the extent that that's even being done reliably at all. And so, I think we can trace a lot of the concerns that people have about bias, about factuality, back to the fact that we're building models that are not, sort of models of coherent individual agents with coherent beliefs, but of a bunch of sort of random snapshots of what people were thinking about at different moments in time. And then there, I guess separately from that, there's an issue of just kind of like computational constraints on what these models can do. And we know that there are planning algorithms that you can't fit into a forward pass through a transformer, and sort of reasoning procedures that you can't fit into a forward pass that goes through a fixed number of layers or whatever. And so there's some other category of reasoning mistakes that these models make just because you like literally don't have enough computational power to figure out what the right next token to produce is. And I think one of the big important research problems right now is more precisely characterizing, really what those computational constraints are and what the kind of limits on the processing power of the models that we have today are, and what the sort of implications are for the kinds of models we need to be building in the future and the kinds of mistakes that we need to be looking out for right now.
Yeah, I mean, that's really what you also mentioned about how these models are maybe thinking unlike people. I think even with just like previous more simpler models. So my background is machine translation. At the beginning of just like introduction of LSTM and transformer models in machine translation, there were some works trying to see whether like the model actually learns like syntax, like these like dependencies, like is it, and it turned out, I think in the end that it is learning some structure, but it might not actually correspond to what we think as like a structure of the language. Yeah, I think it's probably also very similar thing happening here now. So I do want to, I know, I think we named this session as a journey to learn from language. And I know from many of your works how you have been really interested in just seeing how us human beings learn language, and then like what we can learn from that process and maybe see whether these models can do or not. So I do want to ask, and you talked about reasoning, which is, I think, very important, but just language itself, in your opinion, like how are these models actually, are they learning from language, or is it, do you think like the language part is more or less solved and then all of these additional, or you don't separate reasoning and these like more maybe advanced, like next level ways of using language from language itself? So I just want to see what are your thoughts there.
Yeah, I mean, I think it is very difficult to separate language processing from all these other more general, sort of reasoning type, cognition type procedures that show up in these models. And, it's interesting. We work a lot with, and I co-advise a couple of postdocs with Ev Fedorenko, who's a neuroscientist in brain and cognitive sciences at MIT, who's done a bunch of work showing that in, at least sort of anatomically in the human brain, the regions that are responsible for doing language processing, or maybe some subset of things that are we would characterize as language processing are like really distinct from more general cognition. And then, I think there's an interesting kind of interpretability question, whether you get that same kind of like functional segregation inside language models when you train them the way that that we train them right now. Um, but it's certainly not the case, I think, either in human learning or in the way we train language models right now. That you can like look at the training data and say, oh, these are the examples from which the model learns about the syntax of English, and these are the examples from which the model learns about the world, or these are the sentences, these are the contexts in which making the right prediction only requires knowledge of English, and these are the contexts in which making the right prediction, requires both linguistic knowledge and world knowledge, because, at some level, the world knowledge is kind of always there in the background informing what kinds of sentences are likely to come next, or even, whether you need to say the word the in order to produce or, license some grammatical construction that will then allow you to say something that's true about the world rather than false. So, yeah, I mean, again, we talk about these things as language models. I guess now we call language models even things that are trained on like biological sequence data and all these other structured sequences that don't have anything to do with language at all. But even the ones that are producing words as input and output are, again, clearly doing more than just um, language processing. And I guess importantly, they are learning to do that just from text, or almost exclusively from text. And this is, I think, a pretty interesting and, again, important divergence between the way these models work and the way like child language acquisition works, in the sense that, we know for people having a bunch of structure baked in by evolution is important. Existing in a social environment where you're surrounded by other intelligent agents that are trying to interact with you and that are talking to each other sort of intentionally with shared context is important. Having perceptual grounding, being able to, sort of see people pointing at things, or hear people, hear things, touch things. All of these things are really important for being able to acquire language as sample efficiently as people do. Uh, it is then, I think, remarkable that the language models that we have right now are able to learn as much as they are without that social context, without that perceptual context, without embodiment, and probably, plausibly the mechanisms are maybe even more than plausibly. Clearly, the mechanisms by which they do that are pretty different from the mechanisms by which people learn language.
Hmm. Yeah, that's a very interesting point. So I was wondering if the things that you mentioned is uh, inductive biases, essentially, that these models don't have. And I know there might not be like a yes or no answer to this question, but if in your opinion, are these models are still like learning it from maybe the whole text of the internet multiple times, going over a computationally intensive process, or do you think introduction of these sort of inductive biases in some form and shape can still have like added value on like what these models are learning from pure text?
Yeah, well, I mean, certainly in the regime, we train now these language models in orders of magnitude more text than even an adult human learner is going to see in the course of their entire lifetime. And when we train models on sort of human-sized corpora, they don't look anything like the models that I guess the big LMs that everyone likes to interact with right now. And so that's clearly a regime where figuring out what the inductive biases that people bring to language learning problems are, and figuring out how to encode those into models would be really useful for making it possible to train these models at a larger scale. Do the benefits from getting the inductive bias right still carry over once you are actually willing to train on the entire internet, which you may need to do for some of these like more far out capabilities that, being able to write code that most people couldn't write, being able to remember facts that most people don't know, things like that. That I'm less sure about. And so, it is possible that if your only goal is to build like one big language model that can do everything, and you're willing to use all the data that you have your hands on, worrying about low-level architectural stuff or ways of baking structural requires into these models really isn't the right way to go about it. But I think for many people in the field, uh, being able to train things at a smaller scale, being able to get even like 80-90% of the way towards the capabilities of the biggest future models with human-sized data sets, or with data sets that are totally open, or with data sets that are in a particular language where there just isn't a giant corpus. These things are all really important. And then I think there are, just kind of basics, like from a scientific perspective, we're still really trying to figure out and characterize what exactly these inductive biases are that humans bring to language learning problems, and being able to build computational models that operationalize particular theories about what those inductive biases are, and then being able to test those theories out by training these models at small scale and seeing how well those do. That I think is really important for science, maybe independently of all these big engineering questions.
Yeah, that's a very good point. And it's I think it's actually so what you mentioned about characterizing these inductive biases, maybe it's like one side of things. On the other side, it can be the big question of actually evaluation of this. Like, how would we are moving towards a goal to make these models better at understanding language. How then do we actually know whether we succeeded or not? And there are a lot of right now arguments, or just like in general discussions about, once also you have consumed all of the internet, like whether the current benchmarks and tests make sense anymore or not. And maybe like more fundamentally, with these much more powerful models, the question of assessing how well they understand language, how well they can do reasoning. What are your thoughts? I know you have been working on this in a few of your recent papers. What do you think?
Yeah, so I mean, I feel like there's probably not one clean answer to the how should we do evaluation question. Taking a step back, right? What is evaluation, meant to do, right? Or what are we supposed to get out of all these big benchmarks and leaderboards and whatever that say this model gets 80% on this particular task? And there's a category of things that are meant to be sort of like real tests of whether this model can do a particular task that some downstream user thinks is going to be useful. Things like summarization, things like machine translation, where I really just want to know what whether and how far I can trust a model to perform a particular task. And they're, you know, worrying about, well, what happens once you've trained on all the data that's out there, worrying about things like data contamination are important, just insofar as they're gonna maybe cause you to overestimate how good models are. But like, if it happened to be the case that somewhere on the internet was a text file containing every English sentence and its translation into every Spanish sentence, I would be perfectly happy to train a machine translation model on that data set. And that, at that point, there is no meaningful sense in which you can talk about whether the model generalizes, but that's fine because every English sentence is in there. And so whenever I need to do some translation into Spanish, that's going to work fine. Now, obviously that data set doesn't exist and cannot possibly exist, but but basically the function of evaluations in that category is really just to tell us, like, for a random sentence that I'm going to pull out of my hat in the future, is it going to get translated right? And then there's a sort of another category of evaluation that are not really aimed at looking at doing specific useful things, but are models smart, or are models generalizing in particular structured ways from their data sets? And they're, I think, all, but most of the nuance is not, did you scrape the data set correctly and did you avoid contamination, but just, when you are operationalizing things like arithmetic reasoning or, the ability to do long text generation or things like that, are you actually operationalizing them in a convincing way? And then most of the problems that we get in evaluation are not necessarily just from, or the first order problems are just because benchmarks themselves are not testing the things that they claim to be testing, and not maybe some of these lower level things about data set contamination. Yeah, I guess all of which is to say that for things in the second category, the current sort of research paradigm that we have right now, right, where people put up a leaderboard and then people solve the leaderboard, and then somebody comes along and says, oh, the reason you solved this leaderboard is because you didn't actually do the task quite right, or because there's some subtle like whatever spurious feature correlation in the way you generated the data set that makes the task easier than you thought. So here's my new and improved hard version of the same task. Like, that's science working, and I don't think we can really expect people to get all of these evaluation questions right on the first try. And I don't think we should think of it as a like failure of the research process or the scientific method that we build these evaluations and then they turn out to be easier than we expected, as long as, part of the research community and a part of the research process is constantly sort of testing those assumptions. And as long as we make room in our conferences and in our journals for work that does that.
Yeah, I think that's a very good advice. Not looking at evaluation as something static that is just gonna be solved and done. Cool. So maybe taking a step back in general, what excites you in research right now? What do you think would be really interesting to work on?
Yeah, well, so coming back to the sort of how do these models learn? How do we learn? What are the differences between these things? I still think there's a huge amount of room for thinking more carefully about natural language supervision. And, right, for example, if I go to you and I define some new word, right? I say, a wug is a whatever three-legged animal that lives in Central Park in New York. You now not only know that definition, is a sentence that occurs with high probability, but you can imagine all kinds of future scenarios involving this made-up animal, stories that you might tell about the wugs that live by the reservoir, and, people who keep them in their apartments, and the one that's in the zoo, and somehow the like update that you make both to your model of what sentences are grammatical and to your model of the world is some like very complicated, very sophisticated thing in response just to this new definition. If you take a language model and you fine tune it on this sentence, it's going to assign this sentence, what is a three-legged whatever that lives in Central Park. It's going to assign that sentence high probability, and it's not going to change really anything else about what the model does anywhere else. And we have all these fancy editing techniques and retrieval-based techniques and whatever, and none of them really seem to like robustly globally make the updates to a sort of language models world model that you would want if you were going to sort of use this kind of new information in a human-like way. And so I guess one big general category of thing that I'm excited about is making it possible to like make major global changes to everything about the way a language model represents the world by teaching it in language the way that we teach people. And I think this requires, certainly different kinds of learning algorithms from what we have right now. Maybe even before that, a better understanding of how models already represent their linguistic knowledge, represent their world knowledge, where the mistakes are, and how robustly you expect to be able to do something like this with current technology. Another sort of high-level category of thing that I'm super excited about right now is sort of interactivity broadly. And right now, especially talking about like LLMs that live behind APIs, if you ask a question or if you give an instruction and you don't do a very good job of it, what you're going to get as output from the system is a like best attempt at doing whatever this thing that you asked, or best attempt at answering the question, even if the question is underspecified. And again, obviously, this is not what we do in day-to-day interactions. If I ask you a bad question, you're going to ask me a clarifying question back, and building systems that can do that, right? Systems that can ask good questions, that can sort of solve tasks interactively by stopping and saying, hey, I'm not actually sure how to proceed, like human user, can you give me some more advice here? That feels like a really important area, and again, one that I think requires significant research, in the sense that there isn't a lot of evidence for what that looks like on the internet, because most of what's out there is like complete, fully realized documents without the sort of clarifications that go into producing them. But if you had the ability to do interactive question answering and question asking, you could imagine fancier forms of machine learning, fancier forms of active learning, where systems, maybe I'm trying to do a new task and I don't even go out and collect a data set for the task. My system just asks me a bunch of questions to try to figure out how to solve that task. Or for teaching applications, right, where I'm trying to build a system now that's trying to help somebody learn to program or learn to do math or whatever, by interactively coming up with maximally informative examples that you can show to users, or to students in this case, to like help move their own knowledge along. And so my students Belinda Lee and Alexis Ross are working on projects in both of these areas in collaboration with some other folks as well. But I think this is like a big, wide open research area.
Yeah, I mean, these are very, very nice. I think, especially like the first direction that you mentioned, I feel like it goes maybe not necessarily the opposite direction, but it just focuses on creativity of these models with just like introduction of new things, rather than what maybe like retrieval augmented methods, or like trying to narrow down this like the one true answer. So I think that's and we definitely need both. So it's not, I feel like that's very important as well. So yeah, really cool. That's some work
And
on this.
I guess I think it's also worth noting that a lot of this, doesn't just need to be about models of text, that, maybe even in robotics applications more than NLP applications, right? Sample efficiency is super important, and being able to give a robot a demonstration and then have the robot ask clarifying questions, I think could, be quite useful for those kinds of applications as well. And language is a medium not just for learning how to do other things in language, but as a medium for learning how to do perception, how to do interaction with the world.
Yeah, I agree. That's great. Great, thanks. So I do want to get to some of the questions that people have been asking. So if anyone else also have questions, feel free to use the Q&A section. So the first question, which might be also relevant to this discussion that we just had, is from Hugo. So he's asking, what are the limits regarding the types of agents that might be contained within LLMs? And is interpolation enough to mimic all types of human agents?
Right. So I guess this is, going back to the kind of picture that we had at the beginning of a language model as a mixture of all of the data generating processes on the internet, some of which are people and some of which are automated things. And right. So if we think about how to go from that model to something that works like ChatGPT is supposed to be, right? Something that's a model of a sort of single coherent agent with a single coherent set of goals and a single coherent set of beliefs, however you want to think about that. One question is just how much data it actually takes to specify, okay, now here's the like specific individual that you're supposed to be simulating, such that you'll, get responses that are consistent with that persona or whatever from context to context. And I don't think we know, how whether it's like an amount of data that you can fit into a prompt, whether it's an amount of data that you can fit into a fine-tuning data set, just like generally what we need to what the control levers are on a language model that let us say, no, I don't want you to be a model of the entire distribution. I want you to be a model of this specific person. And then I guess to the original question, in the space of text generating processes that you can get sort of, I guess, individual coherent text generating processes that you can get a language model to simulate, does that actually contain everything that we want, or are there things there that are whatever, don't look like anything that we're on the internet, and that would require the model to extrapolate in some meaningful way? Yeah, I feel like I don't actually know the answer to any of these questions, but this feels like something where especially more focused sort of interpretability research, better understanding of the kinds of representations that models build of contexts that they're then using to decide whether, sort of what new information to add to a context or how to avoid contradicting themselves in a context, are the things that we need to do in order to figure out how to steer these models in the way that we're describing. And I guess just to like emphasize this again, this sort of language models as pictures or as mixtures of data generating agents picture coexist with the fact right now that models also make like mistakes that are not consistent with that picture, right? Mistakes that no individual data generating process would make, in as much as they contradict themselves or hallucinate, stuff that's not true that nobody has ever believed. And yeah, and so, I think the other thing that we need to understand is how much, what kinds of things can be done generically to models to fix those kinds of coherence issues before we can start working on the how do I make my mixture of the entire internet into a specific bot, if that's the thing that we're trying to build.
Yeah, thanks. So the next question in the chat is maybe a quick one. Where do you get your data sets? And I guess maybe also in the context of if the data sets you want to work on is not really out there, like what would you do?
Yeah, so I mean, I don't know, my group has many different projects and the data sets come from many places. I guess one thing that I'll say at kind of the meta level is that designing those is a skill, and I feel like not one that I actually possess or have, am the best person to pass on to my students. And so a lot of the work that we do is relying on other big sort of public benchmark things that are out there. The one exception to that is probably the interpretability work that we do in the group, and they're, the sort of design of data sets for answering questions about how, models are representing syntactic or semantic phenomena internally, or sort of lower level questions about what circuits they have for doing particular language processing problems. Thinking specifically like of a bunch of the work that my student Evan Hernandez has been doing, a lot of that is just like him and his collaborators sitting there thinking very carefully about how to design often sort of programmatically comprehensive data sets for exploring, like answering specific scientific questions about how models work. That's a very non-specific answer, but I think there's a category of data set that requires like training skilled human annotators and doing very careful validation that those things are correct. And for those kinds of projects, we mostly rely on the amazing work that the rest of the community has been doing. And then there's data sets that are designed to answer sort of like narrow, precise scientific questions, sometimes that are like single use, thrown away after this paper things. And those we often generate synthetically.
Yeah, thanks. So we have a question about whether or not there are universal representations, in your opinion, across languages. what are your thoughts? Have there been research efforts analyzing if it helps to have data sets of the same knowledge across multiple languages?
Yeah, so I guess the best evidence in favor of there being some sort of language independent representations of meaning inside these models is uh, the fact that you actually do get reasonably good cross-lingual transfer across tasks, right? So I can take a model that has only ever seen whatever medical question answering tasks in English and has seen a bunch of I'm making the languages up here, but Hindi data, but not for that particular task. And you can still ask the model questions in that new language and get answers in it. And to the extent that that is true, I think there must be some language independent representation of meaning and language independent representation of factual knowledge in order to support those kinds of cross-lingual behaviors. Now, caveats as always, right? That transfer happens, but certainly these models are better in language one than in language two, and often they exhibit sort of different biases in language one than in language two. And so here again, I think there's room to do a lot of um, interesting interpretability work aimed at understanding, okay, when you're building a sentence representation, what part of that sentence representation is your language independent representation of meaning, and what part of that sentence representation is still keeping around knowledge of the source language, and then when models are making predictions, what's the circuit that's implementing the sort of like language independent task solution, and what part is looking like just a language model for your task of interest in a way that explains why you get differential accuracy, differential behavior from language to language.
Hmm. Yeah, I think it also goes back to what we were talking about, this whether we can actually isolate these, like there are a lot of works in interpretability, whether we can or not, at least in the sense that we understand this separation. But yeah, that's great. So another question that just came in. So I'm actually keeping one question as the last one. So John asked, what are your thoughts on transformer alternatives, such as the recently released Mamba architecture for language modeling?
Yeah, so I mean, certainly uh it seems unlikely that transformers are the kind of forever architecture. And one thing that I really like about this general category of uh state space models, state space adjacent models, all the work that's been coming out of Chris Ray's group and colleagues, is that these sort of like multiple modes of inference, and the notion that you can train in parallel but decode recurrently, and thereby overcome some of the computational limitations in models right now. I feel like I don't have very strong intuition about like specifically whether these models are the path forward, or specifically what the differences are between uh transformer type models and RNN type models and convolutional type models, and the boundaries between all of these classes are getting a little fuzzy as we realize that linear transformers you can think of as RNNs and all these other things. So yeah, I don't know that I actually have anything specific or useful to say other than that I think it's really important for people to be doing research on these kinds of architectures. And, if we think back even to like the genesis of transformers themselves, that was really very motivated by computational concerns. And then it turns out to be the case that transformers seem to have also very specific, useful inductive biases that RNNs don't have, that they're better at modeling long-range dependencies, that they're better at doing, implementing some of the specific operations that you need for doing things like in-context learning, which is something that my student Ekin Mekirek has been thinking a bunch about. That basically doing modeling motivated by computational concerns can wind up also just giving you models that are more accurate in their own right, and vice versa. So yeah, so I think it's important, and one thing that I worry about in this general direction, is that the tools are just so good, right? Hugging Face is so good, and all of these libraries that let you, use these existing model architectures and decoding algorithms and all that off the shelf uh, mean that the barrier to the sort of activation energy required to try one of these new things or implement your own model variant or even like implement your own new decoding algorithm is quite high. And I feel like I sometimes have to do a bunch of work persuading students that it's worth their time to try doing some of these things themselves rather than using all the nice libraries that are out there. Um, and yeah, and so I think it's important for us as a field uh, that we continue to explore and that we continue to build tools that incentivize exploration.
Yeah, I agree. I feel like it's in some sense it's easier now. Like I also doing my PhD, I went from Lua to Torch to PyTorch, just like everything was coming out at the time, and you had to implement everything yourself. So there is some advantage there, even though it might seem like everything is going slower. But
Yeah,
yeah,
I guess one thing that I will say, I spent so much time during my PhD doing just like elementary calculus to get gradients of functions, and the fact that that's now been automated away, I'm very happy about, and very happy that nobody needs to do that anymore.
nice. Yeah, so next question is from Simon. He says that you've worked a lot on semantics and compositionality, and your work often engages explicitly with linguistic semantics. Are there any big lessons that linguists who work on composition and semantics can take from advances in NLP, or that NLP can take from linguistic semantics?
Yeah, that's a great question. I mean, I think um, one thing that maybe doesn't come like very specifically about the work that's being talked about in the question, but that I'm thinking about a lot these days in the context of like what's the relationship, especially between these big neural models and um, formal semantics, especially, is that there's we used to worry so much about the design of formal representations and trying to get, for some very broad domain of interest, like how do I represent every possible sentence that everyone might ever produce as a little fragment of lambda calculus that like embodies the meaning of that sentence, the computation that I need to perform on the world to get the answer to that sentence. And, I think it's increasingly clear that both in uh, the kinds of things that we want to do in models and maybe even in sort of human cognition, there isn't like a universal representation of the state of the world or a universal representation of meaning, that you're building these little models on the fly that are just big enough to answer um, whatever the question under discussion is, and that there's room there for, or that we should be thinking about there being a kind of plurality of formal semantics is, and thinking about the process by which you choose in the course of doing sentence understanding, even like at what level of granularity you're going to try to represent that sentence and what pieces of its meaning you're going to think of as part of the formal meaning of the sentence and what you're going to offload to more general pragmatic inference procedures. And I think this would have been a very scary thing to say as a person designing semantic parsers and sort of doing formal semantics adjacent work in the NLP literature, even like 5 years ago. But the models that we have today, once you start training on text and code, are so good at mapping from language to logical representations in whatever formal representation that you want, that I think we actually have like very good sort of operational computational models of mapping from language to any kind of meaning representation you want, and that there's therefore a lot of room there to sort of explore these questions about how do you choose the right meaning representation of all the meaning representations that you might have. There's a big group of us at MIT and Stanford that put out a paper on archive, I guess, earlier last year, getting at exactly these kinds of questions. Leo Wong and Gabe Grand. And so, anyway, I could talk about the specific issue for hours, but I think that's the intersection between like modern NLP and modern formal semantics that I'm thinking about most these days.
Yeah, that's a great point of view. Thanks. And one question that I know, so Ravius posted this, and I know a lot of newcomers also in the field are maybe feeling like this and have this question. So they said that I've just started my research journey, and sometimes I feel so lost as there's so much research happening right now. What is your advice for newcomers who just started and wanted to find a good problem that counts?
Yeah, I mean, I think it's really to actually not worry too much about uh what's going on Twitter and all of the new stuff that whatever is coming out every day, and that, at least for me in the past, the stuff that's led to the sort of like most impactful, longest term projects has really come not from, worrying about all of the papers that were submitted to iClear that got published at ACL this year, but thinking about, okay, what are the big linguistic questions, or what are the big questions about like how to do reasoning, and uh, and then trying to come up with solutions to those. And often, when you do, you both fail to solve the original problem that you set out to, but also do something that looks pretty different from work that's motivated by just like very pressing current concerns in the field. So yeah, really, I think the best advice is just to read more papers that were written before the year 2012, and I think in that case, interesting problems that are both important and outside the mainstream will suggest themselves pretty quickly.
Yeah, thanks. And maybe on like the other side of the coin. So because I know you play an important role working with new researchers in your lab. So what are your advice for supervising researchers, especially new ones in the field?
Yeah. So, I think one thing that all new, I guess, faculty members or new people who are research mentors of whatever kind grapple with is whether you want is your legacy going to be like a body of work that comes out of your lab, or is your legacy going to be the set of people that you train? And obviously these things are not in tension with each other all the time, but there definitely are cases where like, okay, I'm really excited about this paper and I could get it out tomorrow if I just like tell the student very specifically step by step what they need to do and then write the entire document myself. Or I could get maybe a slightly different paper out later if I give them a little bit more freedom and let them make a bunch of mistakes and have some sort of like interactive process. And I think especially when you're like a senior researcher and you're coming off of just like being in individual contributor mode for a long time and starting to try to run a lab, the like temptation to, for lack of a better word, think of your trainees as tools rather than trainees is like very strong, and is definitely something that I felt pretty acutely in my first couple of years. And so, I think the most important thing is just to recognize that at the end of the day, one, as an academic especially, your primary job is to train people, and that that's more important than you putting out exactly the paper that you want to put out right now. But that more generally, that's the way to have like an impactful scientific legacy, is not just to like do the things that you're excited about, but to cultivate people who can come up with their own ideas that are better than your ideas and execute on those better than you could. And and I think that's been one of the most like gratifying things as now coming to the point of like having my first batch of students getting ready to graduate, seeing them doing all of these things that are like not things that I would have ever thought to do on my own, and that are more interesting than any of the ideas that I had when I was starting out.
Yeah, great. Thanks. Yeah, so we are unfortunately at the time. I very much enjoyed our discussion. Do you have any final departing words for everyone?
No, I mean, well, I guess coming back to the, how do I avoid getting overwhelmed? I think really just taking a step back, not worrying too much about what's happening right now, and focusing on the big questions is the most important thing. But yeah, thank you so much for having me.
Yeah, that's great advice and a positive note to wrap up. Thanks a lot, Jacob, and thanks everyone for coming to this talk and for the great questions. I hope you have a good day, and yeah, thanks. Bye.
Thank you.